I didn't notice till later. Calendar, here we go. We had you guys starting section 10.6 with me, kind of, sort of, on Friday, even though I was gone. Parametric equations, and then today we're supposed to be finishing so that homework can be due tomorrow. So we're trying to finish section 10.6 today. And then if you guys notice, we have section 10.7, section 10.7, section 10.7, start 10.8, section 10.8, and then, oh no, spring break. Okay, so hold on. So there's no quiz tax day. There's no quiz before spring break, but what do you notice just a couple days after? Now, in some ways that might be bad, but in some ways that might be good. In the sense of it's only a quiz. It's like a quest. It's not a test. It's only on 3 sections, 10.6, 10.7, 10.8. And we will have finished all of the content before spring break. So technically, you could come Tuesday having all your homework ready to go, having the review already attempted. What you do is just go over the review, give you details on the quiz, and then boom, we're ready to go to chapter 12, calculus content by Thursday, which would be super cool. Gavin?
Do we have school that Monday?
No. You have an Easter Monday. Because technically you don't get Good Friday because it's during spring break. Normally we get Good Friday and then spring break, then a whole week after Easter. But since Good Friday is during your spring break, we're giving you like an extra Easter day on Monday. Is that cool?
That's cool.
That is cool. I agree. I know. All right, so is it a good thing we're not cramming in a quiz before spring break? I think so. I think it'll make your week easier in honors pre-cal. But you will get back as soon as Kim and Jason take the test. Get back your chapter 10A test. You can work on corrections over spring break. That'll probably be due probably this Thursday, the day after the quiz. We can also have everything done, ready, attempted, questions, so that this can really just be a question day and a test hint or a quiz hint day, and then we'll be good to go. Any other quick questions about logistics? Okay.
What are we going to do on Wednesday?
Cool.
Half our class.
10th graders, raise your hand. Cool.
Well,
Maybe more than half. Why is Kyle bringing this up? Because the PSAT, yeah. The PSAT, you guys are taking that on Wednesday between 8 and noon, I believe, my 10th graders. However, what do you guys notice? Are we starting or finishing a section on the 10th, on Wednesday? Finishing, which means I'm probably just doing homework helps. And when is homework helpful? When you're doing homework. And when are you doing homework? After school, maybe at home, maybe at school. So therefore, those of you guys missing class, you're just going to want to pull up the video and have it available so you can finish homework help. Now, if you guys notice, hold on, pause. What's also on Thursday? Finish 10.7. So 10.7 homework isn't actually due the day after your PSAT. The homework finish is actually due on Friday. So what you guys are going to do, I'm going to have a shortened video on Wednesday. Half the class will probably be an example or two. The other half the class will just be a work day for those kiddos that are here. And the rest of you guys will finish up with whatever questions you have on Thursday before starting the next section. So I have given a little bit of cushion in the schedule. Does that make sense? The homework probably should have been due here. I made it due Friday, and I'm like, okay, fine. We'll finish up anything extra my 10th graders have as far as questions, and then we'll go to 10.8 also. Sound good? Thanks, Kyle. Anything else logistically? Ready, set, parametric, let's go. Some of you were here on Friday. Some of you were not. So I'm going to go quickly through the notes that you guys were going through. Maybe adding in, because these new notes, or these notes from this year haven't been filled in yet, even though the notes from last year were. Let me quickly do a little taking my master notes and saving a copy for this year. If you guys need a title for this part of your notes, it's technically parametric and polar. We're just going to say equations because depending, you might not understand why they're functions. What did the book call them? Yeah, the book calls them equations too. Good. All right, here we go. Let's see what you learned, and let's see what you can teach me, and let's see what you can teach the other people who weren't in your class on Friday. Ready, set. How hard is it to graph this guy in your calculator? Not hard, except you guys did have to play with your window a little bit, right? Because this graph had a lot of things going on. Like its maximum didn't even occur until 36. Yikes. But in function mode, no big deal. Plug it into your y1, and there you have what we would call a path. There's what in getting ready for parametric equations, there's what we're going to call the path. Now, parameter, as soon as you go to par mode, so calculator's out. Right. Calculator's out. As soon as you go to par mode, so the first one was function mode. And then the next one is parametric, or we're getting into parametric. What's different? We're going to do the exact same graph. If you guys notice, this max, if you use the max feature on your calculator, is 3618. This max is 3618. This one hits at 0, 0. This one hits at 0, 0. And if you were to find the 0, this one has a 0 at 72, 0, and this one has a 0 at 72, 0. But how similar are their equations? The graphs are the exact same, but how similar are their equations? This guy is negative x squared over 72 plus x. This guy is x equals 15t squared plus 24 rad 2t. On Friday, where's the t? No, not that kind. Where's the t? We're not spilling it today. Where's the t? Okay, it stands for time. It says it it says it on the next page, I think. Time keeps on ticking. There you go. But where's t on your calculator? Hold on, pause. Calculator, hit the on button. All my ones whose calculators aren't even on. Go to mode and make sure it's par. Then go to your y equals and tell me where the t is.
Oh, x,
Yeah, x comma theta comma t. T is the par mode. T is the par mode. Okay, now I want you guys to go ahead and get this graph into your graphing calculator. If you don't have it from Friday, because it's very possible we might have erased it Friday and then gotten like some new ones in. So I want you to go ahead and get this graph into your calculator in par mode using that T, which is really the X button. And then I want you to find me on the graph, which you're going to have to play with the window. I want you to find me the max. In function mode, you guys know how to find the max. That's from the beginning of the year, kind of, right? But par mode, do you know how to find the max? And I'm not sure if we went over this on Friday. Did we go over this on Friday, finding the max in par mode? When you're done, Rachel, can you go to the main office and ask them for a refill? Find me the max. Okay, wash your hands and then wash. Whatever's peeling, whatever's hurting, like just put on the one area. Okay? Okay. Okay, now your hands are clean, so go ahead. Hit mode and go down and go to par, P-A-R. Enter. There you go. This is what they're doing right now. Oh, get rid of all this. Ew. Yeah, clear, and then go down, clear. Yeah, get rid of all that. All right, you guys got it? All right, let me show you the window. I'll zoom into the window. So Jason, we're putting this in X1 and that in Y1. And everybody just said T is the X button. Now guys, careful. The square root can't go over the T. The square root has to stop with the 2. And then why is my window so weird? Oh, well, the negative 40 to 80 is just so we can see everything. So we need to be able to see up to here, well, all the way over to here, actually, and up to there as well. But there's this extra T-min, T-max that I should have talked about on Friday just a little bit. And there's some weird things that can happen. If you guys are in degrees, this would not give you a good picture. This would give you an awful picture if you're in degrees. If you're in radians, this will give you a good picture with the T-min and the T-max and the T-step. So if I were you, I would go change your window, or sorry, your mode to be in radians, not only par for parametric, but also radians. But I asked you guys a question. What did I ask you to do? Find the max. Oh, how do we always find the max? We hit the second button, and then what else? Second trace. Yay, let's go find the max. Where's the max? What options do you have under second trace now that you're in par mode? dy over dx, value, dy over dt, and dx over dt. Guess what? Value is the only one that's nice for you. The other ones are all calculus. Oh. Where's my 0? Where's my max? Where's my min? Where's my intersection? Well, guys, hold on. Value. Hit value and then type in 36. So second trace, hit value, and then type in 36. And I want you guys to all compare calculators in your groups, making sure everyone's able to do this. The equations are in. The graph is showing because you've changed your window. You've gone second trace value. Johan and Adam turn. Make sure everybody has it on their calculator. Type in 36. Type in 36. Did Jason get it too? Type in 36. Does it show 18? No. Uh-oh. It says error when you type in 36? For all of you? Oh, what did I have you type in? Oh. So what if we plug in 3 root 2 over 4? Can you plug in 3 root 2 over 4? Because it's a t equals, not an x. I can't put in 36, not a y. I can't put in 18. What happens if I put in 3 root 2 over 4? It gets you the number. Tony? Oh, I don't know. But now, guys, can I have you do something else? Can I have you hit the second format button? Is it the second, third button? Second window or second format?
Boom. Ooh, cord off, cord on, cord off.
Oh. Here. Oh, 400. Yeah, way too big. Because so maybe like 20. There you go. Better. Okay, do you guys see how this is going to be kind of rough? Is par mode good for finding maximums, minimums, and intersections? No, it's awful. For finding maxes, mins, zeros, par mode's awful. You need to know the time in order to plug in. You need to know the t in order to plug in points. So in par mode, well, if it's horrible for finding max and mins and zeros, what's the point? Adam, what did you say a second ago as far as who or what is t? Time. Time. So parametric mode is not good for showing or finding locations on the path, but it is good for showing when an object is on the path. At what time, or for a given time, where an object is. So parametric, here's the difference, guys. There's something on the path that's moving, which is why in this graph, the parametric graph, there are arrows showing orientation is what we would call it, as far as the direction of the movement. Now, you guys should have already seen on Friday how x is going to be its own function and y is going to be its own function, as we already talked about, calling the curve or the old-fashioned graph a path. We talked about how to form a table in some way, shape, or form, saying we need t's, and then we can get the x's and the y's in some way, shape, or form with the table. So now we have 3 things, not just 2. We can technically say that parametric equations, and I don't think I said this on Friday, is really good for 2-dimensional motion. Because you have something that's moving horizontally as well as vertically. Something that's moving horizontally and vertically. So horizontal movement and change and vertical movement and change. Now question, what's a really good speed for like a professional baseball pitcher? What's a really good speed as far as how fast? 590? Oh, high 90s makes so much more sense. I'm like, you guys need to, okay, good. So high 90s as far as like a professional baseball pitcher. That's 90, let's just go with 90 miles per hour, right? Right? Okay. So what if a pitcher, full speed, throws a baseball straight up? Now he'll try to throw it straight up. Will it probably like land, if it does land, a little bit away from him? Like is it going to literally go straight up and straight back down and hit him in the head? Probably not, whether because of wind or whether because of his angle of his arm. Let's say he tries to throw it straight up, 90 miles per hour, and it comes down. But it only goes like a foot. Was it going really, 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 really fast and really, 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 really far in the vertical position? Vertically, yeah, it was going super far, super fast, and it came back down. But horizontally, how far did it go? Not far. So as it's going 90 miles per hour up, it's barely moving horizontally. And so to model that, how it's like, oh, it's going really fast vertically, and it's barely moving horizontally, like it only lands a little ways away. That's why we have parametric equations to talk about, okay, two changes are happening, vertical change and horizontal change, but they're not going to be the same thing all the time. And actually, to be honest, they're usually different. We call them in calculus related rates. They're changing based on each other or in relationship to each other, but differently. Orientation, that's just a little arrow that you guys already saw. So on Friday, you guys should have done this example, right? Sketching a curve. And I said, hey, back in Algebra 1, how did you start graphing stuff if you didn't know how it worked? Plug in easy numbers and see what happens. True? Plug in easy numbers and see what happens. So I had you guys plug in easy t's and see what happens. See? Why is this coming out so weird? I had you plugging in easy numbers and then seeing what happened as a result. So, does -2 go on the graph anywhere? No, -2 is when it was happening, but where was it? Isn't that just the x and just the y? So wouldn't we have just graphed 0 and then -1? And then at -1, when it was happening, a second later, that was sometime in the past. Can we say negative time is in the past? Let's say it's, what time is it? 9:15, this could have been an hour ago, 8:15, 2 hours ago, 7:15. That could make sense, right? Anyway, at -1, it was at -3.5, right? -0.5, thank you, thank you, thank you. I was like, how did it jump so high? -0.5, joop, joop, joop. At 0, so at like right now, present time, we could say it's at -4, 0. Then it was at -3, +0.5. Oh! Fails the vertical line test. And then it's at 0, 1, and then it's at 1, 2, 3, 4, 5. 3 halves, which would be 1.5. Did you guys sketch this on Friday? And after you sketched it, what else did you have to put because of the direction of the motion? The orientation. So you have this little particle. It's moving on this path, on this road, on this track, whatever you want to call it. And the times say, oh, hey, 2 hours ago it was here. 1 hour ago, well, hopefully it didn't take an hour to go from there to there, unless your map scale, this is quite a few miles. Otherwise, it's kind of awkward. Maybe 2 seconds ago it was here. 1 second ago it was here. Then it was here right now. And it's going to be here and here and here if it keeps going at the same rate or the same speed. But what do you notice about parametric right away? Parametric equations, even if they're functions in and of themselves, he's a function. This parabola, if I was just graphing him as x's, him as y's, it'd be fine. Pass the vertical line test. This guy's a line. He's fine. But put them together, does this pass the vertical line test? No, but here's the difference. I could still say these are functions in terms of time. Because at -2, was this particle in more than one place? For the independent variable, how many locations are there? Just one. Isn't that what The definition of a function is for one x, for one input, you're given one output. So for one time, there's one location. One time, one location. One time, one location. Just our brains start to get a little confused because we're so used to one x goes with one y. But now x isn't independent. Who's independent? T. So this is what got a little weird on Friday in that you could have the exact same path with two different sets of equations. Because this one, well, this one takes this much time, 5 units, we can say 5 seconds, to complete this path. This one only took how long? 2.5 seconds? So they're both on the same path, but the speeds are different because the timing's different. He only took 2.5 seconds. He took 5 seconds. He's going faster. Parametric can also show speed. So it is possible in parametric, which is kind of weird to have the same path but different times, and the different times are going to show different equations. However, there is a way to kind of ignore the timing and look at just the path, because it's like, well, okay, what if I don't care about the timing? What if I just care about the path and I care about whether or not they're going the same way on the same road or on the same path? There is a way to ignore the timing. Even though timing is important and helpful, there is a way to ignore it. Ignore. What's another way to say ignore? Eliminate. Nah, maybe not in like life. I'm ignoring them. You're eliminating them. Well, hopefully not physically eliminating them. Maybe emotionally eliminating them from your time and your attention, but careful. Eliminate, to take someone out. Okay. But if we're ignoring, or if we're trying to ignore time, we are going to take it out. In parametric equations, if we're ignoring, is this where we left off Friday? I see people writing now. Have we caught up to something new? If we are going to ignore the timing and just think about the path, if we are going to ignore the timing and just think about the path, we need to take out the t. Ignore the time, take it out. Eliminate the parameter is the mathematical way of saying it. The vocab, if you want to put little quotes around it, it'd be appropriate. Eliminate the parameter, take out the t. How do we take out the t? It's about to get a little creepy, just a little bit. Oh, I guess we could do it like in a non-creepy way. Because spilling the tea is like actual tea, so then we could, well, even do a life lesson instead of talking about assassins. Okay, so maybe not assassins. Let's talk about tea. Crumpets and tea. An AP calculus question a few years ago were about biscuits and tea. That one was fun. They didn't like it, but then afterwards, biscuits and tea. So fun. Same. Hold on, I have to build a whole new analogy. My assassin ones worked for quite a long time. Let's say you only care about X and Y. You can call them two people. People X, person X and person Y. Let's say you care about only X and Y. Person X and person Y. And the T is inconsequential. The T doesn't really matter. You can make this a life lesson however you want. So let's say if you really care about X and Y, you want to disregard the T. You want to love the person and ignore the gossip. There you go. How can we ignore the T? Well, in real life, we can not spread rumors, but even not spread facts that could be harmful to someone's reputation or character before we talk to them personally. But coming back, how do we care about X and Y and disregard, ignore the T and say, oh, no, it's okay, I don't need to know the time. I don't need to know the T. Keep it in the cup. It's safer that way. A lot less cleanup is necessary from spilling. You guys ever realize that? Spilling the tea makes a mess? You ever thought about that? It just got deep. Would you ever just have tea and be like, it's a little brutal, a little mean, and your mom would probably get mad at you. Coming back. But then you're saying that it's up to someone else to clean up your mess, and that's taking away your responsibility that sometimes... Now, you might need some extra paper towels. You might need some extra tools. Anyway, then you need to go get a Clorox wipe because, ooh, that one was sticky. There was some sugar in that one. Anyway, coming back, we're done. How do we care about X and Y and ignore the T? There's a process. Now, I think my assassin example is a little better at this point. But long story short, we want Y as a function of X. If we're trying to ignore the T and just get to the actual root of what's most important as far as the path. We want Y as a function of X. So we want Y to stay right here. We're not going to move him around. We're going to keep him right where he is. Y equals, I love it, but I don't like that. Square what? We want Y just as he is, though. Y is fine. So if Y is fine, keep him. We're keeping Y as is, so let's go play with the other guy. The Y equals I'm fine with. Let's go play with the other guy. How do I play with the other guy? If you were an assassin, you were trying to take someone out, wouldn't you wait for an opportunity where they were off on their own? Wouldn't that be the safest way? Like if you were afraid of their... Okay. So we're going to go over to the other equation and get him alone. I know it's creepy, but it works. Get him alone. How do we get him alone? We solve for him, moving everything else to the other side. Can't I say T is equal to 4x? As soon as I have figured out analyzing who is T, what is he, and he's alone, go take him out. How? You have 4x. Go plug him in. Oh, because then I can go ahead and say this is the same thing as 16x squared. Dun, 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 T's gone. If I go to the x equation and get T alone by multiplying both sides by 4, then I get T is equal to 4x. I know who he is. I can go ahead and take his place. I can go ahead and take his place. If you want to take out the assassin analogy and instead think of something like, do you guys know how some actors have doubles, right? Or even like to certain events, if they find look-alike, they can take their place, etc. There are movies based on this. But anyway, coming back, you can even be like, okay, who are you? Let's make you look just like, yeah, we have T, sweet, perfect. We have the identity. Go plug him in. T's gone. Someone else is there. But let's start off. Now, long story short, get T alone in the x equation and then plug it into Y, and all of a sudden you know the path and you have no clue as far as the timing when the particle is at the different positions. All the timing is gone. All the where are you, when are you, going this way, going that way, I don't know, but I know the path, and the path is 16x squared. Why could that be helpful? How many of you guys knew what this graph looked like way back here? Our brains aren't used to this. Look over here. Which one were our brains able to process better, even though it was tricky? This one, oh, hey, it's a parabola. That's downwards, and I could complete the square, and it's probably shifted somewhat. I can deal with that one. This one, you're like, I don't know, make a table, right? Okay, so our brains are used to that. So even if it might be helpful to eliminate the parameter, even if we're supposed to graph something, it's like, I don't know what it looks like. I'm not used to parametric. This is new. Cool. Eliminate the parameter, find the path, and then go back and say, okay, when T is, here it is, here it is, there's the orientation. Okay, that's how to eliminate the parameter. Whoa, but what if it looks like something like this? And it tells me to sketch the curve. All they care about is the path. They're not even saying show the orientation, just the path. Well, I don't know, it's gross. Well, what did we just say you should do? Start by, nope, don't touch him. We like the y equals. Ha. Who are we trying to eliminate? T. So what are we going to solve for? T. So we're going to take the x equation, and we're going to get T alone. We're going to be strategic. Does anybody have an idea? There are two different ways to go about how to get T alone as far as where to start. What do you think? Do you want to multiply or square? Why would squaring be helpful? How easy is it to square x? Super easy. How easy is it to square a square root? But whatever one you do first, you're going to have to do the other one second. So I said, what do you want to do? Square, or what was the other option? Multiply. Who are we going to multiply by? So I'm going to have x squared times t plus 1 equals 1. Now what? You could. I think I would distribute just to make it easier. And some of you are like, that's not easier. Well, in some ways it is, because now I just have to subtract and then divide. So t is equal to 1 minus x squared all over x squared. Do I know t's equation? Yes. How am I going to use it? Plug them in where it counts.
Whoa, that's disgusting.
Ooh, maybe we could do stealing someone's identity. That could be a new one. It's a little less morbid than assassin. Anyway, go and find all the different and then go take its place. So then we have y equals 1 minus x squared all over x squared all over 1 minus x squared all over x squared plus 1. Let's pull out my handy-dandy trick of simplifying complex fractions. What's my trick of simplifying complex fractions? Multiply by, well, I don't have a nice reciprocal. Multiply by, come on, you guys remember?
The common denominator.
The little common denominator dude, right? The x squared will cancel up here because it's by itself, 1 minus x squared. Down here, when I distribute, isn't that guy gone? And then he's there. Oh, hey, look, a negative x squared and a positive x squared. Oh my goodness. Those equations look disgusting, but guys, how hard is the path? Not hard at all. So if you just care about the path, or if you're trying to get the picture of what it's supposed to look like, you can always go back and figure out timings, like when t is 0, when t is 1, when t is 2. But eliminating the parameter lets us at least figure out what the path looks like. Now let's go ahead, and I had to rework over some things from Friday. But I also want to see where we're at as far as homework helps and getting you guys ready for homework due tomorrow. So, yeah, there were some homework helps we didn't get to do. Okay, so here's what we're going to do tomorrow. Because remember I built in that cushion day anyway for the PSAT people? Tomorrow, let's go ahead and finish 10.6, start 10.7. On Wednesday, I'll give just a few hints on 10.7 to help the people trying to use Wednesday as a work day. But then we'll do probably the majority of 10.7 on Thursday. Sound good? Okay. Can I at least give you a hint on this next page with sine and cosine? Do you guys know a really cool trig property where the trig seems to disappear?
Yes.
So if I could get who cosine is and who sine is, maybe I could make the parameter, which sometimes looks like a theta instead of a t, disappear. Who would cosine equal? Cosine would equal x over 2. Who would sine equal? Y over 3. Ah, it's an ellipse! Bye, guys. Conic sections in parametric mode?